This is the life cycle of a star. All stars start off as clouds of dust and hydrogen gas. Starting in a dense area of matter, gravity pulls the clouds towards each other. The hydrogen and dust are drawn into a circular shape, spinning round and growing in size. The gravitational potential energy converts into kinetic energy as the clouds draw in and pick up speed. This then converts into thermal energy and the whole thing heats up.
So we're feeling hot, hot, hot.
When the swirling mess of dust and gas gets big enough and turns into plasma, turn the hydrogen into H+ ions, fusion starts to occur. Two H+ ions collide, they become an electrostatic force and form deuterium and an electron neutrino. Afterwards, another H+ ion collides with the newly formed deuterium ion to form a 2+ ion and a helium-3 isotope. Then two of these helium ions collide to form helium-4 ion and two H+ ions. When a star goes through this stage it's called a main sequence star. And all is well for now. And then the hydrogen runs out. And this is where it gets interesting. First the star begins to collapse in on itself, shrinking and getting hotter and hotter.
Hot, 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 hot.
The star starts to expand as it fuses helium into carbon using a triple alpha reaction. The star is now a red giant. This will keep going until all the fuel is used up. Once again the star shrinks and forms new elements like iron, which heats up the core even more.
Hot, hot, hot.
What happens next depends on the size of the star. A small star the size of the sun dies out relatively quietly. A big star really knows how to party though.
Boom! I'm party, Arron.
Smaller stars collapse for one last time and stop all fusion. The core shrinks into a white dwarf, while the outer layers are shredded off as a planetary nebula.
Quickly, it's an emergency!
What are you doing, Arron?
Martin, what's a Pauli
Pauli exclusion.
Pauli.
A white dwarf is where all the ionized carbon and oxygen inside the core are as close as they can possibly be due to the Pauli exclusion principle.
Hey, that's my shoe.
Bigger stars collapse and the core becomes an incredibly dense neutron star. The Pauli exclusion principle is thrown out the window when electrons are forced inside the nucleus. Here, protons and electrons interact to produce a neutron and an electron neutrino.
What's up?
The neutron star grows too large, it collapses once again and turns into a black hole.
No, not today. No, I don't think it's a day to turn into a black